Hello everyone.
I am Michael Joshua Dela Cruz.
And I am April Kate Pascual.
Today, we are going to discuss the differences between hashing and encryption and some of their algorithms. Let us define first what is hashing. Hashing is the process of transforming any given key or a string of characters into another value. This is usually represented by a shorter, fixed-length value or key that represents and makes it easier to find or employ the original string. This means that any text, no matter how long it is, can be converted into an array of letters and numbers through an algorithm. Here are some examples of hashing algorithm. First one, we have SHA algorithm. Its secure hash algorithms, or SHA, are a family of cryptographic functions that are used to keep data secure. It works by converting data using a hash function, an algorithm that consists of bitwise operations, modular additions, and compression functions. The hash function then generates a fixed-size string that bears no resemblance to the original. These algorithms are one-way functions, which means that it's nearly impossible to change them back into their original data once they've been transformed into their hash values. Next one is MD5, or the message digest algorithm. The MD5 message digest hashing algorithm processes data in 512-bit strings, which are divided into 16 words of 32 bits each. MD5 produces a 128-bit message digest value as a result. Computation of the MD5 digest value is performed in separate stages that process each 512-bit block of data along with the value computed in the preceding stage.
Now, we are going to talk about encryption. Encryption is the process of encoding simple text and other data such that only the sole authorized party with a decryption key may access it. It will keep cybercriminals from gaining access to your personal information. In current communication networks, it is the most effective method of achieving data security. To read an encrypted message, the receiver must have a password or security key that is used to decrypt it. Here are some examples of encryption algorithm. First, we have ICE symmetric encryption algorithm. The ICE algorithm, which stands for Advanced Encryption System, is one of the most widely used encryption algorithms. The plain text data is first converted to blocks, and then encrypted using the encryption key. The encryption process consists of various sub-processes such as sub-bytes, shift rows, mix columns, and add round keys. Depending upon the size of the key, 10, 12, or 14 such rounds are performed. It's worth mentioning that the final round excludes the mix column sub-process, as well as any other sub-processes used to encrypt the data. Next we have RSA security. RSA is a public key encryption algorithm and the standard for encrypting data sent over the internet. It's also one of the mechanisms employed by the PGP and GPG programs. RSA, unlike DDES, is an asymmetric algorithm because it uses a pair of keys. Under RSA encryption, messages are encrypted with a code called a public key, which can be shared openly. Due to some distinct mathematical properties of the RSA algorithm, once a message has been encrypted with a public key, it can only be decrypted by another key, known as the private key. The technical aspects of RSA are based on the premise that it is simple to construct a number by multiplying two sufficiently large numbers together, but it is incredibly difficult to factorize that number back into the original prime numbers. Two numbers are used to create the public and private keys, one of which is a product of two large prime numbers. To calculate their value, they both use the same two prime numbers. The length of RSA keys is usually 1024 or 2048 bits, making them exceedingly difficult to factorize, though 1024-bit keys are expected to be broken soon. Finally, let us talk about the differences between hashing and encryption. Hashing produces a fixed-length signature while encryption encodes and preserves 100% of the original text. While encryption is reversible, hashing is not. Encryption is a two-way function that includes encryption and decryption, whereas hashing is a one-way function that changes a plain text to a unique digest that is irreversible. That's all for our discussion about hashing and encryption.
Thank you for
watching.